Hello, everybody. I'm Eric Williams, and I want to welcome you to our Parking Structure Durability Educational Webinar Series. It's a new series proudly hosted by the Concrete Preservation Alliance. This is a four-part series where industry experts guide participants through conversations about inspection and assessment, post-tension system protection, targeted corrosion mitigation design, and long-term global protection planning to ultimately provide a practical framework for durable parking structure solutions. Today's session is titled Protecting Post-Tension Parking Structures, Evaluation, Repair, and Corrosion Mitigation Strategies. And we're excited to explore the different approaches to inspection, evaluation, replacing and repairing post-tension reinforcement in parking structures. So if you are new to the Preservation Alliance, welcome. We are a coalition dedicated to promoting best practices in concrete repair and preservation. Our mission is to offer free, accessible, and non-commercialized education, sharing practical knowledge from professionals in the field to support long-term durability and sustainable infrastructure. We extend our sincere thank you to all of our members and supporters worldwide whose collaboration and dedication make the Concrete Preservation Alliance and educational events like this one possible. And if you ever need to catch up or watch any of our replays or past sessions, you can do so by visiting our WeSaveStructures.info website, where you can watch not only replays but download the slides as well. And before we get started, one of the best parts of our webinar series is participation from the audience in terms of questions. So if you have any questions, please do not hesitate to put them into the chat. Please make sure you include your first and last name, because when we wrap up, we'll be giving away a $100 Amazon gift card to the person who submits the best question. And that will be decided by our speaker, who will choose the winner and be able to contact them via email. So with that being said, our speaker today will be Travis Marmon. Travis is a pre-construction manager with Vector Construction. He's been with Vector Construction for over 15 years and has numerous years of experience with not only managing projects and operations, but also business development and estimating. Travis attended California State University, where he earned a Bachelor in Science in the Concrete Industry Management. And he had worked extensively with cathodic protection installation, electrochemical chloride extraction, as well as in press current systems and taking care of post-tension structures. So really appreciate Travis taking the time, and everybody on the call as well. So Travis, I'll kick it over to you, and yeah, take it away. Thank you.
Thank you, Eric. So we're going to start by taking a look at post-tension structures and how we evaluate, approach them, and approach that evaluation, utilize different methods to evaluate that structure, and kind of keep in mind the different objectives of why we are doing the evaluation in the first place. Once we kind of get a sense of what is going on with that structure, we're going to take a look at corrosion mitigation strategies, including drying and injection, and then briefly touch on some of the repairs that you'll see, common repairs that you'll see with post-tension structures, and then utilizing different corrosion protection methods. Unbonded PT was introduced in the United States in the 1950s, and there's over 500 million square feet of PT slabs in the United States. So when we start our evaluation, we need to lay out the approach. How are we going to do this? And the best approach is to try to perform a document review. It's not common, but it's not common that all structures have, good blueprints, shop drawings, and past inspection reports. But if they do have them, it's a good idea to gather those up before you even start. Then we're going to start with the very basic visual inspection. Based off of those findings, we'll move on to looking at other options for evaluation. And if there is a broken tendon, we'll typically pull that broken tendon to see the nature of the break and where it's at, and that's going to kind of guide, further evaluation activities. Once we get a general sense of the structure, we're going to look at tendon excavations and evaluation, and then we can from there go from moisture testing, corrosion testing, and then in situ tension testing. So you can see on the right we have a a set of blueprints from 1982 that shows some of the, it's a two-way slab that has beam tendons and then slab tendons. When we look at the evaluation of a structure, we want to keep in mind the age of that structure. That often will tell us quite a bit about the anchors and then the sheathing around the tendons. Of course, like I said earlier, past documents, we want to look at blueprints, shop drawings, any reports that are available before we even start our field work. Once we start our field work, we're going to do a visual inspection, look at some of the maintenance issues that may have lapsed over the years, and then address those concerns, and then keep in mind change of use or bring to modern standards. Many of older PT structures are, in need of upgrades and strengthening, and this is a time to really evaluate and before those activities start. The other thing to keep in mind, of course, is safety. Safety for the public, the people using that parking structure, the evaluation team, and then any future construction activities, how you might want to phase them. There's a number of challenges when we look at PT over the years. Things have changed quite a bit. So if we look at our top right corner, we have paper wrap tendons that started in the 1950s into the 70s. And you can see that, and then we have different anchors on the bottom, right? We have a buttonhead on the left, and then we have, very modern encapsulated anchors on the right in the green. One thing that I do want to note as we move forward, second from the top, the plastic sheathing, 1960 to present, you can see that sheathing was cut short of the anchorages. In my career, I've seen a number of issues with that kind of detail, and from construction practices from days ago. That can be a vulnerability when we're looking at some of the corrosion issues. In a modern structure with electrically isolated tendons, if everything is installed correctly, care is taken, typically it's pretty tough to get a significant corrosion issue going on. Something to note with the tendons, earlier tendons that weren't buttonhead, like you see on the top left, where we're just using a 7-wire strand, either 0.5 or 0.6. There was push-through tendons, so it was a grease tendon pushed, basically through a tube or, like a hose. Then there's heat sealed; those were wrapped around the tendon, and sometimes that seal would break open and cause a vulnerability in the sheathing. And then there's extruded, and so extruded is it's a tightly formed sheath wrapped around the tendon. You can see the deformations of the wire through the extrusion. Very well bonded, tight, durable. So over the years, material practices have changed. Plastics have gotten better and more durable, more flexible for these types of applications. Whenever we look at a structure, this is a good guide, concrete preservation process. So basically, we kind of start at the very basic part of it, visual inspection, evaluation, kind of the two phases that I identified earlier, right? So we're going to identify issues, right? Cracks, spalls, delaminations. Where are they? How big are they? And where are they in conjunction to the reinforcing steel or the post-tensioning? Corrosive environment. Is this parking structure using de-icing salts to, during the winter months? Or is this structure in a maritime environment, right, where you might have sea spray or salt from the ocean? Water leakage, it's a big deal. We're going to look at the different joints, construction joints, drains, areas that draining, ponding, right? What kind of, how's this structure react to any sort of water? Change of use. They may, with the advent of and wider use of electric cars are heavier. So we might have to look at some strengthening considerations in that respect. Of course, age, I touched on that earlier with the different types of anchors and tendons that are used. Deflection. Are we seeing cracks from overloading, cracks in areas that suggest that maybe something more is going on? Hazardous event. Typically not that big of a deal on an upper slab, but it has happened where they've plowed and there's areas of low cover and it's caught a tendon, something like that. life extension, and of course, wear. Once we have an idea of identifying the issues, right, we want to start with non-destructive testing. That's typically the more affordable testing, easier to perform, and again, it gets us a general overview of what we're doing. So sounding, of course, we want to find where the delaminations are at. Ground penetrating radar, identify the cover over the reinforcing steel or the post-tensioning. Sonic and ultrasonic, that's often used with like columns or bigger cross sections of concrete to see if there's voids or anomalies within that concrete. Corrosion potentials, we're going to touch on that to get a sense of what kind of corrosion activity is going on in that structure. And then we'll go into destructive testing. So in this case, they're using coring. In ours, we're going to do some excavations, open up some tendons and take a look at it. We might want to do some chloride profile testing right along with our corrosion rate and carbonation. Once we perform our evaluation, then we're going to go into the determine the causes, right? Then we get into the develop repair strategy. So that's where we get into budget, service life, all of those types of different considerations. The one thing that I would like to add to that is safety. Again, right? How is there shoring going to be involved? How are we going to disrupt the use of that parking structure? So on. So typical PT features with issues, right? There's a couple of key features I like to take a look at right off the bat when we start doing a visual inspection. We want to take a look, if we can, and look at the grout caps if they're exposed, right? We see the top left corner there. There's some grease or maybe some corrosion rust weeping through around the annular space of that grout cap. Of course, we have our expansion joints on the bottom, dry, cracked. They weren't well maintained over there. There's a high likelihood that snow removal operations have damaged them even more. And then we look on the bottom right where the pen is, that's an anchor assembly right there for a monostrand tendon. So that's exposed. It's exposed to the elements and environment. That's not a good thing. Then we want to take a look at where we have drains, utilities, railings. Sometimes damage is done when they're installing utilities very early on in the life of that structure. An electrician, may have cored a hole for a conduit and hit a post-tension tendon. Visible signs of damage, we want to know what that if there is cracking, how is that in relation to the different tendons, decks, and soffits, beams? Cracking, is that cracking related to some sort of stress, cause, overloading? Maybe some tendons aren't viable anymore and something's getting overloaded. Water standing, efflorescence, and rust, and then erupted tendons. Has the tendon blown through the bottom or the top of the slab, or has it come through the anchorage at the end of a slab? So, like I said, I like to break evaluation up into basically two phases in order from more involved or more comprehensive and then into more targeted. So oftentimes when we look at a post-tension structure, there may not be any past inspections done, so we want to start a baseline understanding of the parking structure issues related to the post-tensioning, right? So this is to initiate the long-term service life of that structure. We have to start somewhere. So now we want to document and quantify findings and deterioration at the present time. And then we, based off of those results, like to take and develop a plan for more invasive testing. As you can see, right, phase one, just keep it simple. Visual inspection, ground penetrating radar, sounding, and then if we're seeing some visible signs of corrosion, do some half-cell corrosion potentials, perhaps along the anchorages, construction joints, in those types of areas. Then we move into the more invasive methods, right? So we base them off of what we found in our kind of phase one evaluation, and we want to know whether the deterioration that we're finding is localized or global, and then identify if the deterioration is based on construction defects, design concerns, and environmental factors. Often it's typically a combination of those three, right? And then what we'll do to employ that kind of phase two, we'll look at doing some investigations, remove grout caps, moisture testing, and then the different types of stress testings. So again, like I said, keep it simple. Visual inspection, right? We're going to look at cracking on the slabs and the beams and the delamination, So you can see in the bottom left, we've got anchorages exposed in this area where we've got visible rust, grout pockets, and delaminations over the anchorages. And then on the bottom right, we have an eruption through the bottom soffit of the slab. And then on the top, or just next to that there, we have areas of low cover on the deck, right? So we've got exposed sheathing of a tendon. What are we going to, what are the next steps and what does that tell us? Again, we'll look at different areas of the slab around the, around the edges. If we can see exposed slab edges and where those anchorages are at, are we seeing visible rust, railings up on the top right there, causing damage, in the area of the anchorages and the grout? Where are the slab cracks in relation to the structure? If they're in the middle of the span, what might that suggest, right? Is it possible overloading? We don't know. There's going to be some engineering analysis done based off of what we find, but we need to document them in order to, scrutinize what is going on with that structure. Then we get into the expansion joints, construction joints. Those are not always that evident, but if there's an intermediate stressing anchor in that construction joint or, a stressing area, we want to definitely take a look at that and see if water has infiltrated into those construction joints and could potentially be causing problems. And then of course, high points, are we seeing, evidence of tendon on top of the slab? And then low points, is there water in it? And I'll show you some strategies and how we evaluate that. So moisture issues, in my opinion, if I get a good rainy day when I'm looking at a parking structure, that's a great day, right? At least one of the days, because I want to see where does that water ponding, where is it leaking through the joints, where might water be infiltrating into those post-tension tendons if it's not a modern sheathing and anchor scheme. So water will definitely tell you what's going on. And then we look at different other methods, right? So we see a pretty good crack in this beam. We're going to scan that and we're going to locate where the post-tensioning is in relation to that crack, right? And then if we do have the plans, we're going to take a look at the design and we see that, hey, this profile, the tendon profile was not installed as it originally was meant to be. Back in the day when they were installing, guys got in a hurry, installed the tendons, and they weren't, now they're not performing like they were designed. Another issue that I want to point out, and I'm not going to get too deep into it, but it can be very serious, is punching shear. So if we see punching shear around a column, it means that things are definitely moving, right? And occurs when a concentrated load from a column causes the slab to fail in a brittle manner on the column. When that happens, definitely perform some engineering evaluation and analysis, and oftentimes just get some shoring on it, remove some of the traffic in that area if you're not sure of what's going on. I'm just going to point it out. Like I said, I'm not a structural engineer. I can't speak to it in depth, but if you see it, definitely remark and notify somebody. Evaluation, visual inspection, right? So we're looking at the midspan of these beams and we're kind of seeing some consistent cracking going on. What does that mean, right? Have these beams been overloaded, or was there a loss of post-tension force inside of that structure? We're definitely going to take a look at that because these cracks may suggest that we've got some flexural loading going on that these beams aren't fully able to accommodate. If we do find a broken tendon, so this was a project I was on recently, we can see off to the left, right, a tendon had erupted through the bottom of the slab. We wanted to know why did that happen. So we pull that tendon and we see which way the break occurred, right? So we found out that, hey, the break, had occurred 17 feet to the right of, where this was being pulled. We measured it out, and then we went to the top of the deck to and we could see in the middle, right, that we have some corrosion issue going on with that strand. and we wanted to see, hey, what might be causing that break? So we found the low spot in the deck at the high point where there's a bollard penetration, and then we know from this structure that they had some control joint issues, and may have nicked tendon, or we know that from further investigation that some of the sheathing on these tendons wasn't well taken care of during installation and damage. So if there was damaged sheathing at a high point, water was able to make its way into the strand, cause corrosion, and then it blew the tendon. Based off of based off of some preliminary investigations and pulling a tendon, then we take a deeper look at, like, okay, systemically, what is going on with this structure? So we're going to designate areas to perform a deeper evaluation, right? To see what's going on. Are there other areas in high points or low points that are causing problems? And what is the overall kind of performance of that post-tensioning system? Because it is a system and it's all working together. Effective testing procedures, right? So we're going to start again, like I said, we're going to go to go from a basic kind of evaluation into a more comprehensive, right? So a lot of times we're going to do some hammer sounding, see where there's delaminations and spalls, and where are those delaminations and spalls in relation to the anchorages, post-tension tendons, and the reinforcing steel that's used to back up the anchorages. Ground penetrating radar to locate tendons. Were they installed per plan? Were they installed with the proper layout? Screwdriver penetration testing, we're going to touch on that a little bit later. It's a qualitative test just to see if there's tension within the strand. And then we're going to do possibly some corrosion potential testing. If we're seeing signs that water is infiltrated to areas that we don't want water to have infiltrated, and we're seeing active corrosion going on, this gives us an opportunity to see the extent of potential corrosion and quantify that. Based off of those results, and if we suspect that there's water or moisture that is made inside of the tendons, we can perform moisture testing. And then if we're concerned about the actual stress in the tendons, we can do lateral deflection and lift-off testing. So ground penetrating radar to locate tendons, right? So we want to definitely check to see if the cover depth is correct per plan. Is the orientation of the tendons, is it correct like we saw in the beam? And then, what is the correct spacing? Scan it, open things up if we need to, and go from there. So ground penetrating radar has become very handy to use nowadays. It comes in a little handheld unit. We can gather a lot of data quite fast, mark things out so that the evaluation activities can move quite quickly. Whoops. And then once we locate tendons and tendons we want to take a better look at, we're going to excavate those tendons carefully. The photo on the left, you can see where we have some intermediate anchors. Well, what does this tell us about its design, right? That the sheathing was cut back, like I had pointed out in previous slides. So what does that mean? Well, in this area, it wasn't too big of a deal because the intermediate anchor is inside of a pretty well protected area that doesn't see a lot of de-icing salts and water. But we do know that in other areas where the anchors are exposed around the perimeter of the slab, having that exposed strands may be problematic down the road, and we found that that was the case. On the right, we see some banded tendons that have been opened up. We want to take a look at the grease, see if there's any standing water, and is the tendon rusty? What is the actual condition of the strand, the grease, and evidence of moisture. Once we've opened up a tendon, a quick test that we can perform is the screwdriver penetration test. It's pretty simple. Just take a flathead screwdriver, put it up against, between two of the wires, and hit it really hard, with a hammer. If the flathead screwdriver penetrates between the wires, that tendon's lost tension. One point that I want to point out on this is that this test is qualitative, right? It doesn't tell us like how much stress. It doesn't tell us. It can give you the tendon may be distressed, and then where we've tested, it may show that it's stressed. So, it's not the best test, but it definitely is quick to do, and it kind of tells us, if something's going on in that particular area. Like I said, once we open up a tendon, we want to be very careful to kind of document and take a good look at and see if we've got presence of water and rust. Definitely if we've got corrosion, pitting, lost cross-section, even if the tendon isn't broken, and then emulsified grease. So what happens over time is that if air or water gets inside of that strand, the grease will get very dry and kind of waxy. And then the screwdriver penetration test. So we're visually going to open it up anyway. Might as well just test it with an SPT test. It's affordable and quick. It's pass fail. Tendon is stressed and not stressed. And like I said, it's qualitative. So it tells us something. It doesn't typically, it's not designed to tell us, the whole story. And then if we do see evidence of rust or grease, around an anchor pocket, oftentimes I'll suggest it, open a couple of them up if you can get at them, like from the end of a beam or of a slab. It's pretty tough to get at the intermediate anchors or the ones that are like in an expansion joint. But if you can, we want to take a look at that. Sometimes we can get enough rust to where the tendon will slip its anchor, right? So the wedges have very, very small teeth. And if we get a bunch of pack rust in there, some aggressive corrosion going on, that can cause a lot of problems. And it's not going to be an overly dramatic release of tension, right? It's just going to slip itself. It's not going to, oftentimes it won't blow through the slab or anything like that. So we want to take a good look, make sure something isn't going on that we don't want to see. If we see something going on and there's a greater cause for concern, shoring, it goes up fast. It's relatively affordable, and it gives you time to really take a look at that structure safely if what you're finding warrants that. Corrosion potential testing. So what this test does is it tells us the probability of active corrosion in bare mild reinforcing steel or in anchorages or paper wrapped tendon. So since a paper wrapped tendon isn't an electrically isolated tendon, we can test the long length of a paper wrapped tendon to see if there's active corrosion going on, just like we would a rebar. So this is a good test around rebar or anchorages, right? If things aren't epoxy coated or not encapsulated in a plastic, if bare end anchors, intermediate anchors, this is a great way to say, okay, we've got a construction joint with some intermediate anchors, but we don't know what's going on. We're not seeing a lot of evidence of something, going on, but we want to check it nonetheless. Maybe water's getting deep down into like a beam or, a slab or whatever. We can do this test to see if there's active corrosion going on in those areas. And of course, around expansion joints, and then, like I mentioned, paper wrapped tendons. When we do that test, right, we want to kind of do a full survey of an area that we're concerned with, and we want to see, what's the higher likelihood versus the lower likelihood of active corrosion going on. This is not going to be possible with fully encapsulated isolated tendons. If it's got a heavy traffic coating or the bottom soffit is painted, we can still do this test. Oftentimes we're going to have to damage the coating a little bit so that our reference electrode can take the readings. This does pair well with chloride testing, especially in areas where they're using de-icing salts or a marine environment. And then, of course, carbonation testing to really understand the quality of that concrete and if active carbonation is going on. I'm not going to touch on that. There's some of the other webinars that address this a little bit more. Great reference for that information. And then we want to identify corrosion hotspots, right? Where are they at in relation to our anchor lines, construction joints, wheel paths, parking spots. So there's times when, or if there's low spots or ponding in, on the deck of the slab, we're going to typically see higher corrosion potentials in those areas. Moisture testing. So based off of our past evaluation, we're seeing that, hey, there's a high likelihood that there's water or, water and moisture getting into the tendons. We want to verify that for sure. We can do that by moisture testing. So we typically use a dry gas. Nitrogen is often what we're going to use. And we use an inlet port and an outlet port, right? And we just pump that dry gas through the tendon with a moisture meter on the other end. If there's water ponding inside of that, in the bottom of that drape, you're going to see your moisture test go up quite a bit, right? So again, we're looking at probabilities, not unlike the half-cell corrosion potential testing, right? We want to know where are our wet cables, our wet dry cables, and so forth. So if we've got water inside of the cables, we're going to know, if we've got 100% humidity, there's ponding water in those strands, which means that there's a high likelihood that active corrosion is going on, especially if there's an inclusion of chloride. Just briefly, just know that these tests do exist. It's not common. One is lift-off testing. It's taking a jack, putting it on the end of the anchor if the tail of the tendon is long enough, and then, putting some tension on it to see what the in situ strength or in situ stress of that strand is, and then lateral deflection testing. And so we'll go to the bottom side of a drape of a tendon, open that up, and then put the frame, the jack, pull on it, and based off of that calculation, tell you what the in situ testing or tension is of that strand. It's not common. I've only seen it a couple of times in my career. Just not that common. Corrosion mitigation strategies, right? So those are going to be possible when, based off of our past evaluation, we have active corrosion present, but it's not widespread, right? To the point where we're, blowing a lot of tendons. A lot of tendons haven't been damaged, to the point where they've lost stress or, erupted through the slab or blown out the end. They're utilized along with a long-term maintenance plan, right? So if we're going to do a corrosion mitigation strategy, we really want to look at coatings, joints, areas where water has been getting into the strands, right? We have to address that. So we can do the corrosion mitigation, but then right on the tail end of that, right, we have to make sure that water and doesn't get back in. Cable drying, it's exactly that, right? So have methods to run dry air through the cables, not unlike the moisture testing, to dry out the cables. And then once that is done, we can either re-grease them, inject grease, or a corrosion inhibitor. One thing that I want to point out is that this work can be phased. So, we may have like a 4-layer or 4-level parking garage. For whatever reason, we're seeing level 1 being the worst. Okay, maybe address that, now. And then you could do corrosion mitigation on, level 2, level 3, every couple of years as funds allow. What I do want to point out in the graph here to the right, so we're typically getting into the structure at the, right around the initial stage of deterioration or between the accelerated rate of deterioration. And then our objective is to go from either A to A prime or B to B prime, right? Our approach now is to, how can we somewhat move the clock back and get more usable life out of this structure. So cable drying process, it's like I said, it's not too different than from just doing the moisture testing, right? We have inlet port and outlet port, and we'll typically manifold it so we can do numerous tendons at a time. Based off of our testing, maybe one side of a parking garage was exposed to more water and, has, a higher likelihood of wet tendons. And so this is what you would do in that area. It might be the whole level, right? It all depends on your test. What we do then is we use, desiccant dryers and pump air into those tendons for 8 to 12 weeks to dry everything out. Once that's complete, here's the manifold setup. So like I said, we'll do numerous tendons at a time. On the left, these are banded tendons. So we got 3 tendons. We can do those at, underneath one plate. It's, try to expedite this the best that you can, right? when we get into intermediate anchors, we'll have to jump from one side of that strand to the other, jump past that intermediate anchor, because typically we're not going to be able to pass air through that intermediate anchor as well as we can through the sheathing, especially if that sheathing is cut back. Monitoring, drying, and data performance, right? So get everything installed, get the desiccant dryers started and running, and then periodically take tests to see how much that moisture now is then decreasing through this treatment. Once we've done the treatment and dried out the tendons, we've got a couple of other possibilities. We can inject grease into the tendons. It can be done. It's not common. Grease is temperature sensitive, and it can get bound up. It's a bit more difficult to inject, or you can use a corrosion inhibitor. This is somewhat new. It's in a developmental kind of phase, but it is work. It does work. It does travel down the strands a lot easier than grease. And of course, if you can get at the anchors, it's going to be the best way to inject those. And then, you can have intermediate ports down the length of the strand, or try to take it to the other end, depending on the design. So let's say we're going to do just some chip and patch repairs, open things up, right? We want to take a look at the sheathing when we do our evaluations. PTI has a couple of approved methods, right? We want to take a grease tape, a petrolatum tape, double wrap it, extend it down the length of the strand to protect it, right? Once we've opened it up and done that damage to the strand to the sheathing to take a look at the strand, we want to make sure that we wrap everything up well again, so that if water or the environment doesn't have any effect on it. And then as for installing new strands, and we've nicked or caused small damages to the sheathing, we can use liquid tape to fix those areas. So repair broken tendons. Not all tendons are broken because of corrosion or saw cutting or whatever. Sometimes they're done by the installation of utilities, plumbing, electrical, saw cutting for whatever reason, and then concrete screws and bolting, right? So if you're putting down a railing, and then sometimes like in high-rise structures, putting up window treatments and using concrete screws, it's not uncommon for tendons to get damaged that way. So I'm just going to show you briefly just some of the hardware that's used when we do fix and do need to fix tendons. We have what's called a barrel splice. Sometimes they call it a splice chuck. It's just an ability to take an old tendon and splice it to a new tendon so we can carry on, right? So let's say we've got a chunk of bad tendon and we need to get rid of it. We're going to rethread that tendon into the old sheathing. That's one way that we can do it. If the geometry is such that we can't get at the end anchors, or we have to stress it from the middle of a slab, right? So we excavate it, get at the tendons, we can use a dog bone. That's in the top right there. And then temporary lock off is bottom left. So we have a tendon that's under tension, but we need to splice into it. We can lock off that tendon, back it up, and before we cut it to add a new piece in. Sometimes they call those troubleshooting anchors. And then there's torque stressing couplers. They can be used. You see them more with precast, but they'll work just fine. And if the tension is not as such that we can use those, great. Are pretty handy. So we get into doing now repairs. So the photo on the left, that's an old paper wrap system where they abandoned the paper wrap system and decided to put monostrand in its place. So the technicians excavated, added new reinforcing steel, new anchors, and then laid everything into a trench and stressed it and went from there to add capacity back to that slab. In the center photo, we have the barrel splice or the splice chuck, right? So we have old tendons. They're still good. We can splice into them and put new tendons going, the red tendons going the one direction. And then of course the dog bone, we have an old tendon and a new tendon. We can't get at the end anchors. We can't really rethread it that way. So we're going to have to stress from the middle. What you don't see is that underneath those red caps, the bare strands extended so you could get the jack on them to stress them. So corrosion protection, there's a number of different strategies. We're just going to touch on a couple of kind of brief ones. So let's say that we've got active corrosion going on with our reinforcing steel near the anchorages, or maybe the anchorages themselves, or with a buttonhead paper wrap system. One of the strategies we can do is we can drill in a sacrificial anode, tie it right to the reinforcing steel, the anchorages, or the rebar, and protect or the strand, the buttonhead strand, paper wrap strand, and we can protect it that way. This is just a scheme here from a repair. So they've done some excavations. They see the strands with the buttonhead, and what that looks like when it's excavated. We know that the other tendons have active corrosion going on based on some corrosion potential testing. So now we're going to add the drilled in anode in those areas to try to be as less invasive as possible and yet still provide corrosion protection of the anchorages. On a monostrand, that can look like this, right? So we have our line of anchors on the edge of the slab, and then we're just going to drill in the anodes right next to it, So fortunately, there isn't a bunch of bar in there and that particular area, so we can get an anode in there. And you can see there's a continuity groove cut. So all of these are electrically tied together and continuous with one another. And we install our anodes into the grouted areas here, patch them back, and make sure that they're wired to the anchors. Surface applied. So again, there's a couple of different systems, right? One is using a distributed galvanic anode over the anchors, grout caps, or soffit, right? So in this case, you would take these, they're a modular surface mounted anode. You can either, install them along the length of the fascia edge of the slab, or on the underside of the slab to protect the anchors and the reinforcing steel that's used to back up the anchors. Another option would be to use metallizing. So you can either use a 99% zinc or an alloy. In this case, you would need to remove this coating. It's probably a cementitious acrylic-based coating. Grind that off, chip it off, get at the anchors, right? So now we're visually inspecting, right? We're already going to open it up, take a look at the anchors, and make sure none of the grout caps are popped and not a bunch of rust is going on. If that's the case, take a deeper look. But if they all look like they're in pretty good shape and we just want to provide some corrosion protection to those, you would be able to metallize the area where the anchor line is at, or the soffit underneath it. So summary and conclusion. So each structure is different, requires a tailored approach to evaluation, which then will lend itself off into a tailored approach for repairs and corrosion protection. Like I said, if possible, document review is a great place to start. It gives you a basis and kind of a plan of attack before you even start your visual inspection. And then based off of those findings, then typically warrant a deeper and more comprehensive evaluation. When in doubt, install shoring. Just a good practice. It's better to be safe. Maintain coatings and joints in vulnerable areas, right? So if we're at that point where we're seeing active corrosion going on and problems, we want to start really looking at what's that long-term maintenance plan looking like, even if the damage isn't that bad, right? Moving forward, how do we, what activities are going to need to take place, right? And then if we do have active corrosion, we have a couple of different options, from drying, injection, doing just simple repairs to more in-depth repairs, and then looking at different corrosion protection options based on, price, long-term use, what have you, all the different factors that go involved with making those decisions. So, questions?
Trav, nice job, man. Yeah, so there's a number of questions that have been piling in, so we'll start to go through some of them here, but really nice job and appreciate you running through all that. So one of the first ones that came in, and this is the first time I've heard this one, so this would be a good one, is: has there been discussion within the industry to standardize the screwdriver penetration test? For example, the weight of the hammer, the width, the length of the screwdriver tip, etc. because I guess this was a frequent point of discussion within the office, especially if we can't verify the results from the previous positive tests.
Great question. So in my research when I was putting the slides together for this, I did find a document where I think it was through a university where they actually did that kind of evaluation of that test, right? Where the researchers made basically like a hammer that they know they could strike the tendons a pretty consistent rate with a consistent kind of force, and then evaluate it from there. To my understanding of it, there were still some kind of inconclusive results, right? And one of the reasons for that is, I pointed out those areas where the sheathing was cut short of the anchorage, right? So that strand may be bonded, right, in certain parts, right? Especially if there's sheathing damage. Or we've been on a structure somewhat recently where there's extensive sheathing damage, right? So large sections of that strand were bonded to the parent concrete. And so we tested here, it tested like the tendon had tension. We tested further down the way, and that tendon was actually in that length, had lost its tension. So my point is, I don't know if there's going to ever be a good way to do that test, because like I said, there's, sometimes there's poor construction practices that have gone on, like damaged sheathing, or it's just cut short, kind of how they did it back in the day. So I wish I could give a more conclusive answer, but I can't.
No, that's fair. And kind of piggybacking on top of that one is it possible to damage the tendon using the screwdriver test?
You'd have to be pretty strong. I mean, I can't do it. And even some of the stronger guys that I work with, right? I mean, those are durable tendons. It's just a flathead screwdriver, get it right between the wires and hit it hard, but I've never really seen any significant damage or nicking done to the tendon by doing that test.
Okay, very good. And this one came in terms of corrosion potential testing, and how viable or how much value is in corrosion potential testing for post-tension structures, since the cables should be encapsulated along the length of the cables, and only areas of exposed steel are the anchors.
Right. So that's a good point, right? So it's not going to, it's not going to, if the sheathing is well placed and in good condition along the length of the tendon, right, we're not going to get any sort of meaningful results. But if the anchors are bare and we have bare reinforcing steel that's backing up those anchors, and we see that there's high active corrosion going on in those areas, right, we know that that's a vulnerability, right? So typically, based off of kind of a visual look at things, right, if we're seeing, corrosion over the grout caps or something like that, then we want to know too, how far does that corrosion extend around those anchor areas, right? Because that's where there's a lot of stress, right, in those areas, right? And so we want to make sure that that concrete is as viable as possible, and we don't have active corrosion going on in spalling. But yeah, good point. You target where you've got construction anchors or construction joints, intermediate anchors, and of course the end anchors if they're bare metal or bare steel.
Excellent. And then this comes up quite a bit, is the use of impressed current systems and post-tensioning protection. You mentioned some of the galvanic options, but one thing that wasn't mentioned here was impressed current. So do you have any thoughts on that, or comments of how viable of an option that would be?
That's a great question, and that was a slide that I had meant to put in here. ICCP, or impressed current, is not used for post-tensioned structures because there is a possibility of causing hydrogen embrittlement. So your best bet is to, waterproof, right? maintain, and then if we do have active corrosion going on, then look at a galvanic system. But we can't use ICCP for post-tensioning.
And
Great
Trav,
question.
not to put you on the spot, but I know you and I have heard that term before, but do you feel comfortable explaining a little bit?
Yeah. So
hydrogen embrittlement and what that means.
Yeah. So impressed current cathodic protection is using an external power source along with an anode. It's a very robust system. Got great technology nowadays so that we can provide a protective current to cathodically protect reinforcing steel in a concrete structure. What can happen, right, if there's too much current going on, because this is a very mild steel. Mild steel is stretchy, that's why we like it, but it makes it more susceptible to corrosion. And so if we have too much current going in through our impressed current cathodic protection system, right, because of our external power source, we can potentially cause the hydrogen embrittlement of that steel. So now that steel isn't as stretchy and viable as we'd want it to be.
Excellent. And I think this is a good leading question to what we just mentioned. So, we talked about impressed current and a little bit about galvanics at the end, but in your experience, what's the most effective and most economical corrosion mitigation strategy for PT parking structures?
Maintenance. Maintenance to start, right? But then once corrosion is initiated, surface applied are pretty good, depending on the density of your reinforcing steel. I mean, it depends on a lot of different factors, right? And the other thing too is that, there's a cost oftentimes, right, of, folks that are going to park in that garage, and now we've removed that parking revenue to do the construction. So we're going to balance that against, the different options. Surface applied can go pretty fast. Like I said, it can be done in phases. Just all depends on the density of the steel, the amount of post-tensioning that's in that structure. But we want to kind of target, large areas of anchorages. Surface applied is a pretty good option.
Excellent. And little shameless plug for the person who asked that, Jordan, is we'll be discussing that pretty in depth over the next 2 webinars in terms of different options for corrosion mitigation strategies for parking garages. So stay tuned on that as well. So the next one comes in regards to ground penetrating radar and its capability to detect corrosion in PT strands and structural steel. And really they're asking, it's non-destructive, so there's no need to expose the post-tensioning. Using a special technician software process can produce a comprehensive heat map showing areas of corrosion, and that can cover large areas of the slab efficiently and cost effectively. So just kind of your thoughts and how you have been using ground penetrating radar within some of these post-tension structures in terms of corrosion detection.
Okay, yeah, that's a good question. So when you scan with a ground penetrating radar, you can have what's called an attenuated signal. What that means is that signal is often, it looks like it's a little fuzzier, right? Which may suggest that you've got active corrosion or, light delamination over the reinforcing steel in those areas, right? And maybe the concrete isn't as competent. I like using corrosion potential testing because in order to do that kind of a GPR scanning, right, you're going to do multiple scans, like maybe one every 6 inches or 8 inches, right? And then, have to map it all that way through the software. I'll love with you. I'm not that sophisticated with the GPR. So what I would do in that case is I would use corrosion potential testing because I'm going to cover a lot more ground a lot quicker, right? And then build my heat map from there. It's going to essentially tell you pretty close to the same thing. It tells you something's going on, in the reinforcing steel in this area as opposed to that area.
Nice. And then next one is question in regards to the drying system and timing of it. So do you find that there's a benefit to delaying the drying period for a bit of time after the membrane and joint sealing has been completed to allow for as much existing or free moisture to migrate out of the concrete?
So if I understand this correctly, so you're going to put a new coating on top of the deck and then do the moisture testing?
I think it comes down to, Trav, is there a benefit to delaying it if, say, you're doing some repairs, moisture got in there, water got in there, you solved most of your other problems of future ingress?
Yeah.
Is there any benefit of saying, okay, well, we stopped that water from getting into the tendon. Now, when do we start the drying process?
I think right then, right?
Yeah.
If you can ensure that you're not, recharging those tendons with water, then you can start on it, right? And it shouldn't be of any detriment.
Okay. And then when you guys are doing your destructive testing and you're looking at the tendons, when are you in between? When do you decide, okay, we're going to replace this one, or we can repair it, or hey, it's left in place and we just have to fix what's around it? Do you guys have like a line of demarcation saying, yep, it's time to replace this one?
I mean, if you see that, like heavy pitting, so your tendon still have tension, right? But if you've got like heavy pitting going on and you can get at it and rethread it, that's going to be probably your best option, right? And of course, if they're broken, then we got to, look at it from a different kind of lens. But if you've got, significant section loss to the wires, there's nothing you can really do except for replace it at that point.
Okay. No, excellent. And then let's see, going through a couple of these others. Have you ever used a Grabb-it cable before? A Grabb-it cable splice?
Yeah, that's
so this gentleman here, for areas where a PT tendon is damaged while repairing mild reinforcing delams, I've used a Grabb-it cable splice. Is that the best option to regain proper tension? Would a dog bone anchor be better for that solution?
That's an engineering question. And I wouldn't know, right? It would depend on, the original design and the stresses that are involved. I know that Grabb-its are commonly used. It's the one that I showed, like the torque coupler is called a Grabb-it, and the one, when I showed the different hardware. Like I said, it's an engineering question. Sometimes we've been allowed to use it. Sometimes, they want a dog bone splice in there.
Okay. And here's an interesting one. Are there ways to replace a corroded or broken tendon from anchor to anchor without excavation?
Not that I'm aware of. I mean, if this anchor is exposed and this anchor is exposed, yeah, if you can pull it and rethread a tendon that way, and then lock it off on each side or each end, and then re-stress it. That's one way to do it. Sometimes there's walls, right, that are covering over the anchors, and or there's an expansion joint or something like that. But if you can go from point A to point B, that's one of the best ways to do it, because then you're not adding any additional hardware or excavations, throughout the length of that strand.
Okay. And then this is one I know a lot of people have run into, is the waterproofing and traffic coating systems that have been used. Is there one that you like over another to help protect the PT slabs? One that says, hey, this is his go-to, and maybe it doesn't have to be a specific name, but an overall system or material that you guys like using that holds up well?
So there's numerous ones, and I'm not a coating guy, that's for sure. But what I have seen, and I really kind of like the design. It was on a parking structure in the Midwest that got a lot of traffic. They did a methyl methacrylate, which is a very durable and robust coating on some of the vulnerable areas. And then the rest of the areas they used a polyurethane. And I thought that was kind of methyl methacrylate coatings are going to be a little bit more expensive, but in like the turn lanes and some of the areas where there's, where it's getting a lot more wear, that's what they use there. And then the areas where they parked, they used a urethane. And I thought that was a good way to kind of, optimize the price and use two different coatings to kind of achieve, something a little greater than the sum of its parts.
Excellent. And then this one, which Trav, I think you've done a decent amount of epoxy injection and to seal these types of cracks in the slabs and things like that. And someone asked the question, what is there a preference between gravity-fed epoxy or route and seal to address the cracks? We want to limit the amount of water that's going through there. And, is there a way to choose between each method, or both methods effective? Just depends, and kind of get your thoughts on that.
Yeah, I don't know, like if one is really better than the other. I think it all really depends on just the installation of it. I've done quite a bit of epoxy injection, and I've done some route and seal, right? And it's typically, what the engineer, we just go with it. They've evaluated and scrutinized those two different methods, for that structure. Price wise, I think route and gravity feed is going to be a bit more affordable than the other option.
Okay. And you got a couple of these comments, Trav. Is great webinar, and people really appreciated it. And then here's somebody who's a little newer to post-tension repair, and the question was, and when doing the actual repairs, is there a concern about removing the concrete and through the repair process and the effects it might have on adjacent tendons or tendons going in the opposite direction?
Great question. Yes. So, we really need to pick and choose our spots when we do any sort of excavations or we're doing repair. We want to stay away from the anchorages, right? Typically 4 or 5 feet. If we're doing, like I showed you, that intermediate stressing line where we excavated down and there's all those tendons right there, there's a lot of concrete in those areas, right? So depends on like your concrete cover, how deep they are. In that case, they were, 16, 17 inches deep. So there's a lot of concrete around the intermediate anchors. Yeah, we need to, when we do look at those activities of either doing repairs or doing excavations, we really want to kind of keep in mind where they're at in relation to the anchors, how deep we're going to be going. All of those are considerations. So yeah, great question. And sometimes we'll do a tendon here, skip 3 tendons, right? Then do another one and then have to go back, right? And so you do them in sequences so that we're not removing too much competent concrete at any one time in an area.
And this kind of piggyback on that question is, okay, you have a bunch of repairs that need to be done. And I think this goes back to a little bit of what you were talking about earlier, Travis, in terms of some of the testing and investigation that needs to be done. But for you, what would you say is the most efficient way to determine whether a leak in a PT garage and basically where it originates from? It could be a failed joint. Is it a crack, or is it a drainage issue? How do you say, okay, we know we have a problem, but then go back to where did it come from?
I mean, like I said, if early on in the presentation, if I'm there on a rainy day, that's going to tell you a lot, right? Is where is that water ponding, moving to? How is it draining off of the slab? Sometimes, there was a structure that I was on 14 years ago, 13 years ago, where none of the drains were draining correctly. They were all plugged, right? And so all that water is, ponded around the drain, but then it's getting into, vulnerable areas on the structure. Caused a lot of trouble, Now, would they have had as widespread of problems had those drains been maintained? I don't know, but I can tell you that having them plugged really caused a lot of problems. But yeah, anytime you can just see how that structure behaves in the nature that it's in, it's going to tell you quite a bit.
So we'll wrap up because I know we're a little bit after, and I want to be respectful of everyone's time on here. So we'll wrap up with this one, and it's more of a overall state of the parking structure in the U.S. question that somebody had in the offices where they worked had leakage issues and had to go through repairs for both of the parking structures in this person's office. In the general state of parking structures in the U.S., are there any risks, specifically those in older structures, who are readily owners to inspect, repair those structures? So essentially, who readily should be inspecting them? What risks are there to not inspecting them or putting those off, or especially, as a lot of these parking structures are getting older and older?
I don't know the answer to that question. Right. So I'm on the construction side, right? And so, and we do get brought in from time to time and, to do evaluation and stuff like that, where we'll team with an engineering firm and provide, manpower to do like excavations and stuff like that. These are assets, and then there's a safety consideration, right? And as time goes on, those two variables really need to be, weighed out, right? Is, what is the safety, the actual safety of this structure, right? If we're seeing some really nasty cracking going on, what do we do next? I mean, and it's, there's instances where, a parking structure is condemned, right? And, it requires demolition. Fortunately, we haven't seen a lot of really terrible, it's not, there is definitely catastrophic damage that occurs, and people do get hurt or worse, right? But I think it's going to end up in either like local jurisdictions, maybe at the state level, of kind of taking a different look at, how do these, what is the structural health of these things, and what are we going to do to prolong it? But I don't have an easy answer for it.
No, and that one, there's a lot that goes into it. And I mean, you mentioned local jurisdictions and places like New York City now making mandatory investigations of parking garages and every so many years and things like that. So, but no, I think that's all the time we're going to have today for questions. So I really appreciate, Travis, you running through a lot of those. For anybody who asked a question, maybe it did not get answered here, Travis will be following up with you directly, and you'll be able to kind of get that answered from him. And speaking of Travis and contacting him or him reaching out, if you have any more questions that maybe we didn't get a chance to go over, or you want to talk one-on-one with him, by all means, you can contact him through that information there on the slide. And then if there's any parts of the presentation that you want to review or look at again, or you can even share it with others, we'll be posting this to our YouTube channel 24 hours from now. There was also a question about slides and things like that. Remember, you can always go to our WeSafeStructures.info website, and the slides and the recording of the presentation will be posted there as well. And then for future events, this was the second one of our 4-part series focused on parking structures and durability. So our next session will be in the new year on January 14th, where Nick Drews will be exploring targeted corrosion mitigation solutions for parking structures. So if you enjoyed this session and are looking for more information like this, by all means, you can scan the QR code on the screen or go to that WeSafeStructures.info webinars to register now. And while you're there, you can check out our environmental impact calculator. That is a free tool that helps you estimate the environmental benefits of repairing versus replacing concrete. And we've actually gone ahead and filled one out to give you an example of what that would look like. And it's actually the ground transportation setter that Travis reviewed earlier in his presentation. And simply by entering the volume of concrete that'll be preserved, we can go through and get approximate calculations for the natural resources that would be saved and how much waste and pollutants would be created if this concrete had been rebuilt rather than repaired. And there's a bunch of data points in there. Some of the ones that are always stand out are CO2 emissions, as well as the amount of energy it would be required. It's similar to heating 5 Olympic-sized swimming pool for this particular project. So pretty powerful tool, and kind of helps show the impact of replacing versus repairing your structure if you have that capability. And with that being said, I just want to really thank everybody and appreciate everybody for hopping on. Thank you to Travis for taking the time. I know this takes a lot of work to get these done, so thank you to him. And thank you to everyone for joining us. Hopefully you'll be able to join us next week as well, or excuse me, not next week, but next month, after the new year for Nick Drew's presentation. And hope everyone has a good rest of the year. And yeah, get out there and we can save some structures. Thank you.